my screen? Okay.
Yeah.
Can you see my screen? Okay.
Yes, I can see.
Okay. So hi again. I am Nayoung Kim from Nuclear and Quantum Engineering Department, and I'm in my master's degree. And it's a great pleasure to introduce my department to all of you. I will talk for the about first half and about general information and NQE as a major. And Sherif will talk about minoring in NQE as a international student for the last half. So first, I would like to talk about what nuclear quantum engineering is. When I say I major in nuclear and quantum engineering, most people think about nuclear power plants only, but it's more than that. So for nuclear engineering, we use natural fundamental nuclear energy to make the most convenient energy sources. And for quantum engineering, we use radiation from nuclear reactions to apply to processes in medical field or industrial fields, as well as materials fields. Yeah. So I'd like to explain in more detail about what kinds of works that we do in NQE. So in large, NQE is divided into four big categories. First is nuclear power engineering. Second is nuclear fusion and plasma. And third is using radiation for new materials. And lastly, we have medical engineering, including imaging and therapies. So first, nuclear power engineering. In nuclear power generation, there are many things to consider from the beginning to the end. And regarding operation of nuclear power plants, there are researches on safe operation, system designs, and things like thermal hydraulics. And also, many professors are working on waste management as well as policies such as nuclear non-proliferation and things like that. So we have a lot of different areas of research. And one example from the nuclear power engineering section is the development of small modular reactor, which is a very active research topic in the world, not just in KAIST. So yeah. And this is another example of using nuclear power. It's a using use of nuclear battery in NASA's Perseverance, which was launched last year and is expected to complete its mission for 1 Mars year, during which its power is supplied by nuclear battery. So yeah. And we also have the field of nuclear fusion and plasma. There are researches on nuclear fusion reactors and plasma propulsion and many more. Recently, one professor in our department developed a sterilizer using plasma to sterilize things like facial masks and shields from medical fields. So it's actually in the market. So we do those kind of research as well. And third, we have medical engineering, and medical engineering encompasses both radiotherapy and medical imaging. In order to effectively treat a disease, you need to be able to have a good image of your body as well as have a efficient and yet less damaging therapeutic technologies. So there are professors working on both fields. There are researches on CT, MRI, PT, and radiotherapy using X-rays. And lastly, we have radiation science for new materials. We use ionizing radiation to change the structure of materials, and we also use radiation to investigate the properties of materials. So these two facilities you're seeing right now is a research reactor using neutrons and synchrotron accelerator using X-rays. And researchers utilizing these two facilities resulted in 24 Nobel Prizes. So it's a pretty big field. And so this was a kind of introduction for what we do in nuclear and quantum engineering department. And so as an undergraduate student, why should you choose nuclear and quantum engineering for your major or your minor? Yeah. First, Engg in KAIST is a world leader in the field of nuclear and quantum engineering. The number of publications from KAIST is greater than University of Michigan, which is a top-ranked university all over the world. So you can see that Engg in KAIST is quite good. Yeah. And you can also see that the output of students in from NQE in KAIST are quite comparable to those in MIT and other top schools in US. So if you come to NQE, you can take high quality lectures from professors who have great research background and passion for undergraduate students, and you can study collaboratively with other students as well. And second, we have grant support for students. We have scholarships and internships from the government, but also we also have funds from the department itself. So there are currently as of 2021, we have 17 scholarships available for undergraduate students. So it's quite good given that we have only few students in our department as an undergraduate student. So yeah, you can earn money while you can study. Yeah. And third, we have a lot of global experiences for increased students. There are multiple dual degree programs with Sweden, France, Italy, and Spain. But for now, we have dual degree programs for master's degree only. So this may not affect you right now, but it's good to know. So I'd like to introduce this as well. And last but not least, we have a promising career ahead of us. This is not limited to jobs in Korea. There are career opportunities literally all over the world, given the specialty of our field. Studying and researching in NQE and KAIST place you in a good position to work in anywhere in the world. There are government-funded research centers like Argonne National Labs or other Oak Ridge National Labs, and we have private companies. We have universities where you can become a professor, and we also have international organizations like OECD, IAEA, and United Nations. So you have a lot of opportunities to become a leader in this field. And I would like to emphasize about professorship because if you graduate from NQE in KAIST, then you're twice more likely to become a professor than when you major in other departments. So it's a good thing. And given that you are international students, you have more opportunities to become a leader in your own countries. So it's a good thing for you. Yeah. And another thing is that NQE has a lot in common with other fields. It's just not nuclear power. It has nuclear physics, nuclear fusion, and many other fields. For example, materials. And we also have AI-based operation. And we also have chemical and biological engineering regarding waste management and other radiation effects. And we also have mechanical engineering, industrial engineering, and environmental engineering as a part of our field. So if you're interested in any of these fields, then you might also consider doing NQE because it has a lot of common things. Yeah. So when you come to NQE, you are expected to take certain courses, and I would like to suggest a roadmap of those courses. So there are required courses for all students. So in the second year, you can take fundamental courses and which you can learn from scratch without any background in physics. So fundamentals about nuclear and quantum science, introduction to nuclear engineering, and the interaction of radiation with matters. So it explains the basics of information that you need to be able to study in NQE. And next year, the third year, you can take experiments, radiation measurement experiments, and nuclear reactor theory, which is a higher level version of Introduction to Nuclear Engineering. So it's not much different. And for the last year, you will take experiments and design projects for nuclear power plants. So this is required mandatory courses for all students. Now, if you want to take if you want to specialize in nuclear energy, then you can take these courses. So for second year, you can take energy, environment, and water, which in general talks about energy, not just nuclear energy, but also other renewable energies. And third year, you can take nuclear thermohydraulics and computer simulations and nuclear chemistry that are used in nuclear power plants. And in the last year, you will take systems control and just general nuclear fuel cycle. Yeah. Now, if you are interested in radiation technology, and by radiation technology, I mean using radiation for material science and medical fields, you can take these courses. So it has medical physics and materials using stuff about material science and X-rays, neutrons, and radiation biology as to how radiation affects human health. And in the last year, you will take an experiment in quantum engineering. So you will actually use quantum beams in your experiments. So it's a good thing. And if you're interested in medical physics, such as radiotherapy or medical imaging, you can take this certificate curriculum. So yeah, it's good to be informed. So I included this as well. So if you're interested, you should look into this as well. And lastly, if you're interested in nuclear fusion or plasma, you can you are recommended to take these courses. So it has generally an energy uh, energy course again, and just simple mathematics and physics for nuclear engineers. And we have fusion and fusion engineering course for this specialty. So these are recommended courses. So you can take some from fusion and plasma and some from radiation technology, but just an idea of how you might design your course for the 3 years. Yeah. And for last part of my presentation, I would like to introduce what students do after graduation. So basically, when you graduate undergraduate from NQE, 88% goes to continue the study in graduate school. And I think this may be because most of the students in NQE are male Korean students. And because of the military issues, a lot of them go to graduate school. And this may change I don't know, over the time, but I think that's one reason why the number of students going to graduate study is high. But I also think that this may be because nuclear and quantum engineering is generally a field where research is really active. So yeah. And when you graduate master's program, again, 70% goes to PhD. So yeah, and when you graduate PhD, about half of people go to national labs, and the other 40% ish people go to industry. So you can see that um, a large portion goes to national and governmental jobs. So yeah. So to summarize the research fields that we have in NQE, first we have nuclear power engineering, and there are about I don't know, a few 10, 20 10 about 10 students 10 professors who are working in this field. And we have 3 professors in nuclear fusion and plasma. We have 3 professors in radiation for new materials, and 3 professors for medical imaging, medical engineering section. So if you're interested in, I don't know, these sections, then you may look into their websites and see what they are doing for now for their research. And these are some research topics that we are doing in NQE. So as I said before, we have some small modular reactors, we have submarines, and we have magnetic field reconstructions. And we also have a sub-miniature X-ray cancer treatment device, which was developed a few years ago and is in market as well. So yeah. And lastly, what we envision to do in the future, there are several topics that are undergone. So we have energy, and we have generation for reactors, and we are trying to combine AI with safety technologies. And we are also working on fusion energy. And for radiation and medical engineering part, we are trying to develop uh, quantum beam based therapy and measurement technologies. And some new fresh areas of research include space, national defense, and national security fields that are combined with nuclear and engineering. And we have quantum sensing technology as well that we are trying to develop. So these are some ideas for the future. And I think, yeah. So until now, I've talked about general information about NQE, and now Sherif will talk about NQE as a minor, and how it's like to do a minor in as a international student. So I will stop sharing my screen, and
Yeah, okay, Sherif, you can share your screen, and I encourage you again. You can ask questions in the Slido, so please don't be shy and ask, because you have like this great opportunity to ask whatever you're interested in. Okay, let's start with the second part.
Okay, can you hear me? Hello?
yeah, we can hear you.
Okay, thank you very much, Nayoung. Hands down, Nayoung has covered everything concerning our NQ department. Most importantly, covering what exactly our department does, which may be ambiguous sometimes, as well as covering active research fields, career prospects, and all efforts of the department in providing students with chances as scholarships and internship chances. Uh, I will be covering a couple of topics that are a little bit more directed towards international students for now. As an international student in KAIST, I know most of us come from countries that may have no active nuclear programs, which we could say most of the efforts in this field are directed towards. So I understand this could be a reason of not having NQE as your first major, as it can seem risky or a very specific field of study. However, at its core, nuclear and quantum engineering is an extremely large and flexible field that has to do with everything concerning nuclei and radiations, which are practically everywhere. So this has been discussed before, but I want to elaborate more on what I just said. So on the slide, there are some fields which go hand to hand with NQE. For example, physics is a very integral part of nuclear engineering. And the very famous field where physics and nuclear engineering are applied together is nuclear fusion, of course. And from what I see in the department and in most of my classes is that a lot of students who study nuclear engineering are also physics majors. There's also nuclear chemistry, a very active field, which is simply like anything that has to do with reactions due to nuclei, opposed to the usual electrons causing reactions. Then the knowledge from mechanical, industrial, and civil engineering is very important to, especially power reactors. There must be everywhere in the power reactor there will be some aspects of this kind of technologies and knowledge from these fields. Then we have also the biological and medical engineerings are very related to nuclear and radiation technologies, like from cancer treating devices to things like sterilizing our food to make sure it's edible and safe. Lastly, the materials engineers are expected, of course, to always provide new materials. For example, materials that can withstand heat or it can withstand radiation in nuclear power plants and reactor cores. So, to summarize my intent for the last slide, if you don't feel like taking NQE maybe as your first major, then in many cases it would be a solid minor or even a double major. So simply a minor in NQE requires 21 credits, at least five of them are major required courses. On the right-hand side, these are all the major required courses in the department. So you only need to take at least 5 of them. You could take more, you could take less, you could take other major elective courses. And just to note is that as a minor, be careful when choosing the courses because NQE courses are either only spring or only fall courses. So it's only given once per year. So you can never like expect the schedule or like predict the schedule clashes between your like major and minor or major and double major. So it would like if you plan on taking nuclear engineering, then maybe have like a plan from the beginning and divide your credits, divide your courses, just like a rough plan so that you won't face problems afterwards. So as an international student, I actually find NQE to be one of the more international friendlier departments in KAIST. I think I always have international students with me in class. And I can see international students in the NQ department building all the time too. So on average, classes have maybe 10 to 20 students. It's not that much. However, maybe 3 to 5 of them are international students on average too. So, which is pretty significant if you ask me. So it's, of course, it's not big as some other departments in KAIST. in the number of international students, but in NQ there is a continuity of seniors, of international students or seniors whom you can ask for advice or resources, and room to have people from the international community around you, which is very helpful, like most of the time, like all the time actually. And so also, finally, the language barrier is not an issue at all. Same as courses in KAIST, all courses and resources are in English. Coupled with the fact that NQE department has very similar structures to US nuclear engineering departments, whether it's the syllabus or of courses or the books used. So all in all, I'd say the general vibe in NQE is very welcoming of international students. And yes, I'm finished, and Nayoung will wrap up this presentation briefly with the last part in the Q&A session. Thank you very much.
Okay, so for the last part, I just like to say that if you're interested in QE, you can contact the undergraduate representative, Min-hye, by her email, or you can contact graduate counseling assistants, and I'm one of the 2 assistants. So you can contact me or Sung-ho as well. So if I am in nuclear fuel cycle laboratory, and stuff that we do is waste management and some simulation codes and working with chemistry in the fuel cycle. And Sung-ho is in medical imaging and radiotherapy lab. So if you're interested in those fields, then you can contact him. So, or if you have just general questions about undergraduate program, you can contact Min-hye. So these are the information for them. And if you are interested in one particular research field or area, you can contact professors by email anytime, because our professors are very passionate about undergraduate students as well as graduate students. So just feel free to contact them anytime. And yeah, that's pretty much everything for our part. So thank you for listening. And if you have any questions, then we can answer them, hopefully. Yes, thank you.
Okay, so we have actually one question, but well, but it's related more to quantum computing, so I'm not sure if the presenters will know about this one. So
you can, yeah, you can ask me and I will see if I know anything.
Okay.
If I don't, yeah.
So let me share the question. So the question is about quantum computing. Do you think it will become the new norm, and how prospective this would be?
As far as I know, I don't really know much about quantum computing, and I don't think we have research on quantum computing in our department. So there's not much really I can say. Yeah, I don't know. Yeah, sorry.
Okay. Guys, if you have any other questions, I think you can also ask here, or because in the Q&A we don't have that many questions. So yeah. Also, I will share with you like general information about major tracks and a required number of credits, and like basically information which is useful for any undergraduate student at KAIST. So you can check that out also. And here is the link to the informations. So yeah, anyone has any question? Okay, so we have few more questions. Okay. The first question is NQE competitive against other popular engineering like mechanical engineering?
Popular as in to undergraduate students or as in career-wise?
Well, let's see if the person can specify.
Because if he means popular in for undergraduate students, I don't think so, because after the nuclear phase out policy in Korea after in 2017, the number of students declined like a lot. So we have about 5 to 6 incoming students every year. But if you're talking about job wise popularity, it's quite prospective, because there are a number of people that are required for certain jobs, but there are less people coming in, so you have more choices, more options than people majoring in other departments, because in those departments they have a lot of students for same jobs, but we have a lot of jobs and little people, so yeah.
Yeah, I can. Yeah,
yeah.
I can actually confirm that one, because I'm myself graduate from radiological physics. I'm doing something different, but even in Europe, there's not enough people like for anything related to nuclear science.
I think it's the same for every country in terms of nuclear and quantum engineering. I don't think there are a lot of people studying that field, so it puts you in a good position when you get a job. So I think it's good. Yeah.
Okay, and we have one more question. I think this question is more on Sherif. How much is the workload if I want to double major and have NQE as additional minor?
So you mean as in 2 majors and then a minor in NQE, if right? So if that's the case, then uh, I'd say nuclear engineering department is not an easy department. And so about the workload, of course it would be not easy. I mean, and you would still need the same amount of credits from NQE to count as a minor. So 7 courses. And I would think there would be maybe some kind of a problem with like taking all required courses in time. I mean, schedule clashing and stuff. So I think it's doable, of course, if you take more time. But in general, NQE is not an easy department. It's pretty challenging. In some courses are pretty challenging. So I mean, the workload. I think it's a little bit subjective. I've seen. I think it depends on the person and his background and his work ethic and stuff. But I think the workload would be on the harder side. Thank
Can
you.
I add to Sherif?
Yeah, of course.
I've seen a lot of students majoring in other departments, but I think that I can say with quite of certainty that the workload in NQA is quite low compared to other departments, because if you look at mechanical engineering or electrical engineering, the workload is really big, but compared to those big departments, the workload in NQE is not much. And especially if you're doing this as a minor, then it won't be as burden as if you do a minor in other departments. Yeah, and quite a lot of NQ students agree with me. So yeah. Oh, but like I'm not saying it's going to be easy, but it's less difficult, I guess. Yeah.
Okay, we have another question. Is NQI worth in your perspective as an undergrad course?
As in, was it worth majoring in NQE as an undergraduate course? Is that what the question is?
Yeah, I personally think so, but
Okay.
there's no addition right now. So yeah, let's put it that way.
I think it depends on what you want to do. So if you want to do stuff in nuclear power plant, yes, definitely. But if you're interested in the application of other technologies in nuclear power plants or radiation engines, then maybe not. So it really depends on what you want to do. But if you want to, for example, do radiation therapy or medical imaging, I think it's worth the time. And yeah, I think it's I think it really depends on what you want to do, because what we learn in NQE is very specialized knowledge, and if you think you need that to do research or work in places, then I think it's worth it. And personally, I think it was worth taking NQE as my major. But I think it's also good to take NQE as a minor or a double major, because NQE is quite specialized area, whereas mechanical or electrical engineering is a general kind of department. So yeah, I think it's open to both. Yeah.
Okay, we have one more question.
Mhm.
You mentioned waste management. Could you talk more about how waste management is related to NQE? I'm very curious about this.
Oh, I was talking about nuclear fuel, spent nuclear fuel, or wastes from nuclear power plants. So as far as I know, what we do is we are using certain agents or processes to decontaminate the metal wastes from nuclear power plants and the nuclear fuel cycles, like mining of uranium or the steel components from the nuclear power plants. So we are working on the processes to recycle those steel structures or the fuel itself. So it's not just the technology that we're using to deal with nuclear wastes can be applied to other kinds of chemical wastes as well. So yeah, but what I was referring to as waste in that waste management was nuclear waste, spent nuclear fuel. Yeah. So, but if you're interested in just general chemical waste management, then you should do chemical engineering, I think. Yeah.
Okay, I think we will have to finish soon. So let's answer this one more question. Which one is more popular after NQE, PhDs, professorship, or industrial research or job?
I think it depends on whether you're Korean or international student. For Korean students, they usually go to government-funded research centers like KERI or those big Korea nuclear institutions. But I've seen a lot of international students going back to their countries for as a professor in their countries as a professors. So yeah, or their national labs. So, but just in general, people usually get jobs in national labs or universities. But I think for international students, professorship is more popular. Yeah. Yes.
Okay, I think like if we don't have any more questions, or if Nayoung or Sherif have any any more remarks, we can slowly wrap up this meeting. So yeah, I thank you. I thank especially to Nayoung and Sherif that they came and did this presentation for us. I hope it was useful for all of you. And yeah, let's see you each other in KAIST someday. Bye, guys.
Yes, thank you.